Introduction. Today we will learn about the physical quantities, units and measurement. Do you know in which quantity temperature is measured? Yes, temperature is measured in Celsius. Good, but standard of temperature measure is Kelvin. But sir, why do we need a standard in each quantity? We use a standard to measure a quantity internationally and globally. Now we study the units and measurement and concerned topics. Objectives. At the end of this lesson, you will be able to define units and measurements, understand measurement of length, measure mass, measure time, analyze errors, understand significant figures, write the dimensional formula and equations, understand dimensional analysis. Units and measurements. Measurement play a very vital role in the study of physics. Measurement of a physical quantity requires A. A standard in the form of which the quantity is to be measured. B. Numerical value which represents how many times that standard has come in the physical quantity. Units are classified in two categories. They are A. Fundamental units and B. Derived units. A. The units of fundamental quantities are called fundamental units. B. The units which are derived with the help of fundamental units without involving any numerical value are called derived units. The International System of Units. Internationally, 4 systems are used for length, mass and time. A. MKS system, that is meter kilogram second system. B. CGS system, that is centimeter gram and second system. C. FPS system, that is foot pound second. D. SI system, that is International System of Units. Measurement of length. As you know, we use meter scale, vernier calipers, screw gauge, etc. for the measurement of length. We use some indirect methods for A. Measuring large distances and B. Measuring very small distances. A. Parallax method is used to measure very large distance. For example, distance between Earth and Moon. Let us understand with an example. A girl is observing the rod against a wall from 2 different points P and Q. She notices that the position of the rod seems to change with respect to the wall. This is known as parallax. The distance between P and Q is called basis. B. Tunneling microscopy is used to measure very tiny distances because it has very high resolution. For example, calculation of size of a molecule. Measurement of mass. Mass of a body is defined as the quantity of matter contained in a body. There are 2 important physical quantities related to mass of a body. These quantities are inertial mass and gravitational mass. Inertial mass. The mass of the body is determined by measure of the inertia of the body. The greater the mass of a body, greater is the force required to produce a given acceleration in the body. F is equal to ma or m is equal to F upon A. Thus, a very heavy body has a larger inertial mass than a light body. In order to measure the inertial mass of a body, we make use of inertial balance. Gravitational mass. It is the mass of a body which determines the gravitational pull due to the earth acting upon it. In order to measure the gravitational mass of a body, we make use of common balance. The mass of an object is determined by comparing its mass with that of known masses. In terms of atoms and molecules, the standard unit of mass is Unified Atomic Mass Unit, that is U. 1 unified atomic mass unit is equal to 1 U is equal to 1 upon 12 of the mass of an atom of carbon-12 isotope including the mass of electrons is equal to 1.66 into 10 raised to the power minus 27 kg. Measurement of time. Any phenomenon that repeats itself can be used as a measure of time. The measurement is based on the counting of repetitions. The unit of time in all the system of units is second. Some techniques to measure time interval are given as electrical oscillators. These use an alternating current supply of frequency 50 Hz. The rotations of a synchronous motor run on this alternating current are used to obtain a time scale. Electronic oscillators. Electromagnetic oscillations of very high frequency are produced by a semiconductor device. The small time period of such oscillations can be used to measure small time intervals. Quartz crystal clocks. A quartz crystal shows piezoelectric effect. The oscillations produced can be used to measure time intervals. Atomic clocks. These clocks make use of periodic vibrations taking place within the atoms. Radioactive dating. This technique is used to measure long time intervals by noting the ratio of the number of radioactive atoms which have undergone decay with the passage of time to the number of surviving atoms. Carbon has been used to estimate the age of fossils. Error. The result of every measurement by any measuring instrument contains some uncertainty. Error in a measurement is defined as a kind of uncertainty. The accuracy of a measurement is a measure of how close the measured value is to the actual value of the quantity. Precision tells us to what resolution or limit the quantity is measured. There are three kinds of errors. Number 1. Absolute error. It is the difference between its measured value and actual value. Number 2. Relative error. It is defined as the ratio of the absolute error in its measurement to its actual value. Number 3. Percentage error. It is the product of its relative error with 100. Example. Let's take an example of errors. A capacitor of capacitance C is equal to 2.0 plus minus 0.1 microfarad is charged to a voltage V is equal to 20 plus minus 0.2 volt. What will be the charge Q on the capacitor? Use Q is equal to CV. Let us see the solution. Q is equal to CV. On calculating, we get Q is equal to 40 into 10 to the power minus 6 coulomb. Error in C is equal to 0.1 part in 2 is equal to 5%. Error in V is equal to 0.2 part in 20 is equal to 1%. Error in Q is equal to 5% plus 1% is equal to 6%. Therefore, charge Q is equal to 40 plus minus 2.4 into 10 to the power minus 6 coulomb. Significant figures. Significant figures in a measurement are defined as the known digits in the measurement. Number of significant figures in a measurement represents the level of its accuracy. It means more the number of significant figures in a measurement, more accurate that measurement is. Let us take an example. 1.000 centimeter is most accurate as it has 4 significant figures. Rounding off. It is a process by which number of significant figures can be reduced as per requirement. Let us take an example. L is equal to 2.6587 centimeters. On rounding off, L is equal to 2.659 centimeters. Example. Let us take an example of significant figure. Sides of a cube are measured to be 6.052 meter. Find out the volume and total surface area of this cube to appropriate significant figures. Let us see the solution. Volume is equal to length into breadth into height. After calculation, we get V is equal to 221.665 meter cube. The number of significant figures in each of the measured components of the product is 4. Thus, the calculated value of volume should be in 4 significant figures only. Thus, V is equal to 221.7 meter cube. Total surface area is equal to surface area of 6 faces. After calculation, we get S is equal to 219.76 meter square. Each product has components with 4 significant figures. The final result also should be in 4 significant figures. Thus, S is equal to 219.8 meter square. Dimensions of physical quantity. Dimensions of a physical quantity are the powers to which the fundamental units have to be raised to express the unit of that physical quantity. All the physical quantities can be written in terms dimensions L, M and T. Dimensional formula and equations. Dimensional formula of a physical quantity is an expression within a squared bracket in terms of fundamental units with their powers. Let us take an example. Dimensional formula of velocity is equal to under brackets m to the power 0 L t to the power minus 1. It is an equation which is obtained by equating the dimensional formula of a physical quantity with its symbol. Let us take an example. Dimensional equation of velocity is V is equal to under brackets m to the power 0 L t to the power minus 1. Dimensional analysis. The magnitudes of physical quantities may be added together or subtracted from one another only if they have the same dimensions. Uses of dimensional analysis. A. To convert a physical quantity from one system of unit to another. B. To check the correctness of a given physical relation. C. To establish a relation among the given physical quantities. Did you know? The International Bureau of Weights and Measures is an international standards organization, one of 3 such organizations established to maintain the International System of Units, SI. The organization is usually referred to by its French initialism, BIPM. Electric units called international for current and resistance were introduced by the International Electrical Congress held in Chicago in 1893, and the definitions of the International Ampere and International Ohm were confirmed by the International Conference of London in 1908. The way temperature scales used to be defined, it remains common practice to express thermodynamic temperature, called T, in terms of its difference from the reference temperature T0 is equal to 273.15 Kelvin. the ice point. This temperature difference is called a Celsius temperature. Summary. Let us summarize what we have learned. Physics is a quantitative science based on measurement of physical quantities. Certain physical quantities have been chosen as fundamental or base quantities. The International System of Units (SI), based on 7 base units, are at present internationally accepted unit system and are widely used throughout the world. The SI units are used in all physical measurements for both the base quantities and the derived quantities obtained from them. Physical measurements are usually expressed for small and large quantities in scientific notations with power of. In computing any physical quantity, the units for derived quantities involved in the relationship are treated as though they were algebraic quantities till the desired units are obtained. Direct and indirect methods can be used for the measurement of physical quantities in measured quantities. While expressing the result, the accuracy and precision of measuring instruments along with errors in measurement should be taken into account. Dimensional analysis can be used to check the dimensional consistency of equations, deducing relations among the physical quantities, etc.